Good evening everyone. My name is Akshay Kumar. Today I am going to present our class presentation as part of assignment 2 where I am going to discuss about the solution of crystallographic point group and dataset solution of zip file using OLX and Vesta. So first of all I am going to discuss about the crystallographic point group of that crystal which is provided in class. So to understand the point group here, I've taken different pictures from different angles. So this is the front view of that crystal picture. So if we imagine a C2 axis which is perpendicular to the screen, which is possible, and if we try to gather the info from different angles, then here are the two views. One is top view on the left and another is horizontal view on the right. On the top view we can easily visualize that if we consider a mirror plane which is cutting the crystal into two halves, and if we consider another mirror plane in horizontal view which is parallel to C2, which is also possible, and if we gather the information and gather the different the different symmetries and different possible mirror planes, so we can conclude that the point group is MM2, which is under the orthorhombic, because MM2 has 1 2 4 axis with two mutually perpendicular mirror planes parallel to it, and which is the solution of this crystallographic this crystal. The next I'm going to discuss about the data set which is provided to solve using the OLX and Vesta. So this is the data 1. So I solved using OLX, and as we can see, like we can visualize a hexagon here which is a benzene ring, and in this structure we can see, okay, there are some small balls and some uh, there is a difference in size. Why there difference in size? That is because of UISO, and that we have learned in class, that isotropic displacement parameter, uh, mm, which we have learned during the Debye-Volov factor, that where we consider the atomic vibration that will lead to the different size, the role of ADPs, and this is the crystal structure basically. The next is the information that where we can visualize, okay, what is the R factor, which is quite promising, 3.959%, and we can also look after for different parameters like R int, which is internal R factor, which tells about the data quality, the internal agreement of intensities of the reflection, the internal R factor. And here is the crystal packing that I solved using the Vesta, or we can figure out a pattern of symmetries, like how the crystals are arranged in a long range. And if we look after look diagonally, then we can easily see, okay, there is a pattern in crystal packing. And this is the PXRD data I solved using the same software Vesta. We can get the information between the intensity and the 2 theta, and it is a solution of crystal structure of data file 2. So I used the ins file using OLX software, and I solved this structure. And this structure we can see, okay, there are some the small balls and big balls that also represent, that we have discussed in the previous slide. And as you can see, there are different color of different balls which represent different elements present in the crystal structure. And here is again the data where we can conclude the R, which is also promising, which is 3.78 and R int and other values, which tells about basically the R int, the internal R factor, just discussed before, and the crystal packing of a crystal. And this is also quite understandable, that how crystals are arranged, and there is a symmetry, and diagonally we can also see, okay, there is a symmetry, and the crystal packing is quite symmetric. And here is the PXRD data. I solved this also using Vesta software, and this is the last one, the last dataset file, um, which I also solved using OLEX software. And the crystal structure, there are also the different balls of different colors representing different elements. And as you can see, the purple ball is representing phosphorus and the oxygen connected to them, which is possibly a phosphate, which is interacting with the hydrogen using the O, and the oxygen anion connected to the phosphorus. Next, um, the R factor is also quite promising here, 3.18, and the other data can also be visualized, that the cell parameter and the angles, the alpha, beta, gamma. And next is the crystal packing. The crystal packing, this is also solved using the Vesta, and the crystal packing also can be visualized. Okay, like there is symmetry uh, in the arrangement of crystal, the diagonally also, and just by rotating it we can figure out different type of angles where we can visualize, okay, there is some pattern which is following by the crystal arrangement, and which gives a very broad picture of crystal packing. And the next is the PXRD data, basically which tells about the intensity and the Bragg reflection relationship, where we can get the information about some certain peaks and the certain idea of the crystal, that certain morties are present, and which are reflecting the X-rays, or we are getting the information. And this is it, and thank you.